Hello everyone, welcome to my YouTube channel. And the question for today is short encoding of words. So, we have given a string S and it contains basically different strings. So, we have to encode it. So, we have to encode in such a way that the length of the shortest we have to return the length of the shortest reference string possible of any valid encoding of words. All right, so what is mean by this is given a string array of words like this which contains different string, we have to return the length of a reference string in this case as we given to us as time hash and bell. So it's 4 and it's 4 plus a hash for this one as well. So 4 plus 2 is 10. So in this case we will return 10. So we have to encode it. So the given things we have given to us is word.length is indices.length. The reference string s ends with the hash character. So the hash character, it should end with the hash character. For encode it, we have to uh, end it with an hash character. All right. For each indices I, the substring of s starting from indices I said add up the next is. What does mean by this? All this is that if it contains any substring like this, then we have not to include this. It will be included in this only. So we have to make a reference string such that it contains only the unique string and not the substrings that are there, and after the encoding we have to return the length. All right, let's see the approach for this question. This question is quite difficult and it's not easy, but if we could understand the approach for this question, then to code it would be very easy. All right, let's see how we will be going to solve this question. So this is the question, and let's see for the approach. Let's see with the help of an example. So like this we have to return our encoded string. All right, so as we can see from the looks only, if it contains any substring, the reference string, or the if this has a substring like this in anywhere, then we have to ignore that substring. And also, so one thing we can do is we can just check for the substrings and remove them. As you can see, this is not the substring. It has the three letters same but not all the letters. This string has all the letters same as time and also this. So it can be excluded in any case. So one thing we can do is, number one is we sort it on the basis of length, as the bigger strings will be in the beginning and the substrings that we will be using will be in the end. And if we sort it and then we apply our algorithm like this substring one, then it will be passed, but it will have a great complexity because of the sorting thing. Because for sorting we will need by length, if we sort we need a complexity of n log n in the best case of any sorting algorithm. All right, so it will result in a higher sorting order. One such more thing we can do with this is we can store this in form of trie. As I think all of you are familiar with the trie data structure, it is nothing but it store the values in a form of an array tree in which each character is stored at a given point. And in this case we have to find for the substring, so we will store this string in the backward direction. Suppose our parent node is hash, so we will go for e, then m, then I, and then T. All right, and me will come, so we won't store it because it's already there. For fame it will be E, M, then A, then F. So it is a new word. All right, okay, are you getting my point? So we will be using the help of tries to solve this problem. and trie is like this data structure. All right, so we will go traverse this every word from back and try to store in a trie. All right. So the question is how we are going to implement this trie. As we know, there is no trie data structure in Java preloaded, so we have to make it. But we are going to just make one more thing add to the trie, that is the count. Alright, at every level we will have a count of how many nodes are present. For this the count will be 0, for this the count will be 0, but for this value the count will be em, it will be 2 in this case. All right, and so we at every level what we are traversing, we will add this node to our hash map. All right, we will store a hash map containing every string that we come across and with their indexes at which they are present, because at the end we will traverse this hash map only and we will look for the strings which have their count equals to 0, because if their count is equals to 0 then they are the unique strings and they are not the duplicate ones. So we will be considering their length, and their length will be only we can get in O of 1 using the length function of a string. All right, uh, I know this is a problem bit complex for everyone, but if you can think in a way of implementing it through trie, then it would be more easier. All right, and we have taken hash map for storing the current node of the trie as well as their indexes at which they are present in the words array. All right, so we will be storing them like that, and we will be traversing to backward direction. As you can see, because we have to reference it with the hash value in the end, so we are traversing in a backwards manner and storing them. So I think it is clear now. If some of you might have doubts at this point, then it would be clear when we see the code for this question. Now let's see the code for this question and it would be more clear to everyone. So this is the code of this. We have taken a trie node. This is a basic structure. We have added one variable, that is count, and it's initially initialized to 0. All right, and this function I will tell you when we will use in the main code, then why we are using this function only. All right, now let's see. This is our trie for storing the value, and this is a hash map for storing the current trie node and their indexes. All right, so let's see this what this loop is doing. All right, so for an I is equals to 0, I give word dot length I plus plus. We will first get the first word that is present at the ith index and store it in the word, and we will take a current node and that will be pointing towards our trie only. All right, so this is the main part. All right, so we are traversing in the backward direction. I told you why, and for every character we are calling this get function. So what we are doing in this get function is that if it's if the character value passed to it has no child or has no further subnode, suppose like this is the our first value, and time is what we get now for this character, because we are traversing it in the backward direction. This will be the first character, so it will see that it is not initialized, so it will initialize it in a new trie node and increase its count to 1. All right, it will keep on doing so until and unless we are ended with t. So here we ended with t. The count will be incremented for each and every value for which there is an initialization. All right, so if for everything it count will be 1 and count will be 1, and for this value the count will be 0. All right. Are you getting my point? Okay. So now and then we will put this level t0 comma their index in our hash map. All right. So we will keep on doing this. Now the next thing will come, that is me. All right. Then first we go to e. It is not null. So we will return this whole try to it. Then we will check for m. It is also not null. Then we will return this whole try to it to this current, and then we will put this value, this whole try value, in our hash map and their corresponding index. All right. So this will keep on doing for every word. All right. Now after a while, when all of this value has been set and our try is completed, then what we will be doing is we will just be taking computing our hash map, and we will our key value is try node. So we will, for every key node in the key hash map, if its count is 0, that means that it has not occurred any more times. So what we will be doing is we will just get its integer value at the location where it's present in the word string, and we will compute its length and add 1. We are adding 1 in this case for the hash value that we will be encoding. All right. So because in that test case our answer was 10 because of this fame hash, so the length was 10. All right. For these two we are adding 1. So for every value in the node hash map, if its count is 0, that means it is unique and there is no further substring or anything like that. We will just take their length and add 1 to it. After that we will return our answer. So answer will be storing the lengths of everything. All right. This I didn't explain in the approach. I just explained till here, but I gave you some idea how we'll be computing it. And I think the +1 what we are doing here is clear to everyone why we are adding 1 to it. All right. Let's try to submit this code. As you can see, it is accepted. I am telling you again, it's a very complex problem. Please understand it carefully. And also, if you have any doubt, you can ask me in the comment section. Alright, please like this video, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Goodbye.